tutorial on using Google Sheets for graphing. Google Sheets is really powerful because you can share your data with your lab partners and work together on these graphs and data. So we're going to start with a really simple graph. We have some data here for acceleration and force. The first thing I want to think about is how do you order your tables? Now think about it this way. X, Y, right? X comes before Y alphabetically. The first column is going to be the x-axis and the second column is going to be the y-axis. So if I'm going to graph these two right now, so I'm going to select the data that I want to graph, then the acceleration is going to be on the x-axis and the force on the y, which makes this a force versus acceleration graph. Okay, so I've selected the data. Now I'm going to go up to Insert, Chart. And Google Sheets will automatically create a chart based on your data, and it does not look the way you want it to. We will always in this class be using XY scatter plots. So we're going to scroll down here and choose XY scatter under the setup, and that looks a lot better. But there's still a lot of work to do. So we can't use the graph the way it is. We're going to go into Customize now, and we're going to go through each of these things and update them. Chart style is fine. Now axis titles. You always need to have all of your titles on your chart. So I'll start with the chart title. This has all the different choices. So the first one is going to be the title overall, which we said was force versus acceleration. And then next we have our horizontal axis. Remember I said the x-axis is accel, so I'm going to say acceleration. Remember to always, always, always keep your units. So this is meters per second squared or meters per second per second. Then the vertical axis label will be force, and this is going to be in the units of newtons. And so that looks really good. Okay, so we've got all our titles. Now we're going to scroll down and go to series. Okay, so series is the data set that we have. It's basically all of the different forces for our given accelerations. And this is a really important part because we need to have on any graph we do in physics a trend line or a best fit curve. So if I click that, Google Sheets will automatically create it. Now they've come up with a line, a linear best fit curve, which looks pretty good for this particular data. This does look like it's got a linear relationship. Notice how the line kind of goes partway in between. It just sort of averages the distance between these data points. It's using a statistical algorithm to come up with that line, which is wonderful because that means you don't have to. Now, the other really important part about having a best fit curve is you want to show what the equation of that line is, and that's another thing that Google Sheets will calculate for you, which is wonderful. So we go down here and we click on Use Equation for Label. And then there it is, the equation for this particular line that Google Sheets has determined is the best fit curve. Now check this out. It says force equals 0.921x plus 0.039. This is in the format of y equals mx plus b. Y is the vertical axis, mx, m is the slope, x in this case is acceleration, plus b, and that's where it crosses the y-axis, of course, that's the y-intercept. So that is super useful important information because this slope has meaning, and you're going to learn what the meaning of that slope is when you get a little further along. But oftentimes you're going to be graphing something and saying, well, what is the slope? What does it represent? Okay, we're going to keep going. This graph is still not great. Legend is fine. We don't have to worry about that. But the horizontal axis, I don't really like the way it starts at, I can't tell, 0.2 or something. So we want our graph to start at the origin, 0, 0. So I can define where that's going to start, where it says minimum value. So I'm going to put 0 for the minimum value. Ah, that looks a lot better. So now I have the origin here. And so the rest, the vertical axis looks fine. I don't have to make any changes to that. So that graph is now looking pretty good. Is there anything else I want to deal with? Vertical axis? No, that's fine. Grid lines? Those are fine. So I'm good. Now I've got my graph. So now I want to take my graph. I want to put it into my lab report. So I'm going to go and open up a new Google Doc. I would assume that you already have one open, but you want to drop your graph in. So I'm going to go over here, click on my graph, and I'm going to go over to my Google Doc. I'll give myself a few spaces and drop it in there. And it's going to give you the thing, link to spreadsheet. And the answer is yes, you want to do that because if you find a mistake in your spreadsheet and you go back and you fix it, it will update the chart in your lab document. So that's always a good idea. You're also going to want your data, so grab your data, copy it, and you get your nice little data table. Oh, you know what? I'm looking at this, and here's something odd about this data. Notice at 0.8, it doesn't have 0.80, but the other ones do have 2 significant figures, so you can update that. And this 0.2 instead of 0.20, you want to have the same number of significant figures generally when you're doing measurements. So by using these zeros, you can play around with the decimal places. So I want to have 2. So there we go on both. So I'm going to go here. I'm going to do that again. Good. Now I've got the correct number of significant figures in my data table. Now I'm going to copy my data table, and I'm going to go back to my document and paste it, and it looks good. Notice it says update, because remember we had changed the significant figures. So if I click that little button, then the graph updates to the way the other one was. So that's why I say you want to have it linked. Okay, so I'm going to go back now and show you one more graph and a little bit of magic that you can do with these Google Sheets. You can have Google Sheets do calculations for you. And oftentimes when I'm doing a data table, if I'm collecting data, I'll have it be like a white background. But if I'm going to do a calculation field, which I'm going to show you how to do right now, then I make it gray just to show these are calculated values, not like values that I measured and wrote down. So this is some optics data, and this is an object distance and an image distance. It's like when you're looking through lenses. So what we want to find is what is 1 over the object distance, because it turns out that becomes important in optics. So to find out the value of 1 over the object distance, if the object distance is 0.88, I want 1 divided by that. I'm going to let Google Sheets figure it out, and I do it by saying equals, and equals says here comes a formula. So I say equals, I'm going to go 1 divided by, now I want to get this 0.88 value, so I just click on the box, boom, and it tells me that C4, that is the location of that cell. So it's going to give me 1 divided by C4. If I hit enter, 1.1. That's really slick. Now I want to do 1 over the image distance. Equals, okay, that's saying we're going to do a function, a calculation, 1 divided by the image distance. And so it says D4. That's the cell location D4 of this particular value. Enter. Okay, that's pretty magical. So it just calculated those values. But here comes the real magic. I want to do it not just for this value and this value. I want to do it for all of these values. And so here's what you do. If you select both of these cells and you get this little blue box, you grab it and you pull it down. And voila. It just went in and calculated the values for every single occurrence. It says 1 over C6, so it moved down. It's smart enough. It has, these are called relative references. So it says 1 over, and then the cell that is 2 to the left of the cell you're in. So that's pretty magical. So you should really want to work on getting skilled at using Google Sheets to do simple calculations for you. It's very efficient. Okay, now I want to go ahead and graph this again. So I go here, I select my the values I want to graph, I insert chart. And I'm not going to do all the steps on this one, but remember I do want to go to XY scatter. Okay, and then customize. And I will do my axes titles. You know how to do those. But remember, series is where you want to go and, oops, not scroll that, let's scroll this, is where you want to click your trend line under series. And up, this looks like it is another linear trend line, so that's great. Here are the other choices, though, exponentials, polynomials, logarithmic. Typically, we'll use linear and we'll use power series. And that is about it throughout the course of physics in this year. So, oops, lost that again. I want to get that trend line, but then I want my label to show the equation, and there we have my y equals mx plus b form. That slope has meaning that it has to do with the focal length of the lens, but we can get to that when we get into optics. Okay, well that concludes our little demonstration. Good luck with all of your graphing.